This is problem 23 of chapter 14 of the textbook Stats Modeling the World by the authors BVD. So this is a probability problem about M&Ms, and what they've done is they've given us the proportions for all the colors. So yellow, red, orange, blue, and green. They didn't tell us brown. So that's the first question. So we're just going to dive right in here. So what's the probability of brown? I'm going to use B. So, well, basically what we do is we add these all up and then we subtract that from 100, and we see that we're going to get, oh, that was bad. We're going to get 30%. But to model this, and again, these are actually simple problems, but so you want to practice modeling things so that when they get complicated, you know how to do it. So it's actually 1 minus the probability of yellow plus the probability of red plus the probability of orange plus the probability of blue plus the probability of green. Okay, so that's going to equal 1 minus 0.2 plus 0.2 plus 0.1 plus 0.1 plus 0.1, and that's going to equal 0.30. Okay, that's all you need to do. Now, what's the probability of yellow or orange? Okay, well, or is an addition, so that's the probability that it's yellow. Let's see, plus the probability that it's orange. And if we factored in, you know, if we could subtract off the probability of both, but it can't be. That would be 0, so we don't need that. So let's see, the probability of yellow, I believe, was 20%, and orange is 10%. So 0.20 plus 0.10 equals 0.30. Okay? Now, what's the probability that it's not green? So we could add up all the colors. We could sort of write this out right here, only that it's not green. So we would add up yellow, probably yellow, red, orange, blue, and brown. So it's pretty straightforward. You can kind of see, but an easier way might be to just say it's 1 minus the probability of green, right? And that'll give you all the other ones. So it's 1 minus 0.1, so that's 0.90. Okay? And then they must have thrown this in just for fun. What's the probability that it's striped? So that would be 0. That's never going to happen. Okay. Now, what we're doing is we're going to pick 3 M&Ms in a row. And they want to know, the first one is the probability that they're all brown. So, again, this is like chapter 15 stuff, but we draw a tree. So it's either going to be brown or not brown. Okay, so then brown, not brown, and this would continue too, but we won't model that. And then one more, brown, not brown. Okay, like that. So we're interested in this branch. So it's a multiplier. Okay, so the probability of brown and brown and brown, that's going to be the probability of brown times the probability of brown times the probability of brown. So the probability of brown we already found out was 0.3 times 0.3 times 0.3. So that's going to be 0. I think 0.027, right? 3 times 3 times 3 is 27. So that looks about right. So this would be, this is, if you labeled it, 0.3, 0.3, 0.3. So 0.3 times 0.3 times 0.3. Okay, so that's how we do that. Let's see. The third one is red. So the probability that the third is the first red. Okay, so once again, we can kind of model this with a tree. We're going to either have, it's going to be red or not red. And then we're going to go this way, right? Because not red, red. And then finally, not red, red. So this goes on, but we're going to go this route, and then that route, and then this route. Okay, so the probability that it's not red, let's see. Well, that would be, so I'm running out of room here. I'm going to cut this out. Move it down here. So this is going to be the probability of not red times the probability, or actually, I guess I should write this out. It's and not red and red. Okay, two ands in there. So now this becomes the probability of not red times the probability of not red times the probability of red. Okay, so we can use the complement here. This is going to be 1. This can be 1 minus the probability of red, because not red, again, we'd have to add all these up. So why don't we just subtract the probability of red? So 0.20, 1 minus 0.20 times the probability of red, so 0.20. So this is going to be 0.80 times 0.80 times 0.20, and it's getting late, so let's use the calculator. So 0.8 times 0.8 times 0.2, 0.128. Okay, so 0.128. Alright, so last one. Oh, I guess there's two more. Let me cut this. Put it down here. The probability, we want to find the probability that none are yellow. So that would be the probability of not yellow, and not yellow, and not yellow. That's equal to, because they're AND functions, we multiply probability of not yellow times the probability of not yellow times the probability of not yellow. So again, we could use the complement 1 minus the probability of yellow. That adds them all up for us. 1 minus the probability of not yellow and 1 minus the probability of not yellow. Okay, we could kind of figure it out, but it's just really it's 1 minus 0.2, so it would be 0.8. So that's going to be 0.8 times 0.8 times 0.8. Clear. 0.8 cubed. So 0.512. Alright, now last one. At least one is green. Oh my God. Alright, so let's see. We may have to draw this whole thing out for this one to figure this out. At least one is green. So it's either going to be green, not green. Okay? Green, not green. Green, not green. Okay, one more time. Green, not green. Green, not green. Green, not green. And finally, green, not green. Okay, so at least one is green. So let's check. This is green, green, green. So we'll count that. This branch is green, green, not green. So we'll count that because 2 is at least 1. Then green, not green, green. So we count that. And then green, not green, not green. So we still count that. And then down here, not green, green, and green. So we count that. And then not green, green, and not green. Not green, green, and not green. And then finally, oh no, I can't say finally just yet. Not green, not green, green. Okay, so these all have at least one green, except for this one. Okay, so what we would have to do is we'd have to label these probabilities. Probability of green is, what was that? 0.1. So 0.1 and 0.9. 0.1, 0.9. So we label all these. And we'd have to multiply. We'd have to multiply all these out and then add all these probabilities. That's a lot of work. Okay? So, but we know that these add up to 1. So what we could do is just find this probability and subtract that from 1. In other words, probability of at least 1 green is equal to 1 minus the probability of not green and not green and not green, which is 1 minus the probability of green, not green, times the probability of, not green. Messed that all up. probability of not green times the probability of not green. So probability of not green is 0.9, so it's 1 minus 0.9 times 0.9 times 0.9. And that is going to come out to be, let's just do it, 1 minus 0.9 times 0.9 times 0.9 equals 0.271. 0.271. Okay, so that's how you do these problems. So go back through them however you want. Notice that I'm spending a lot of time using notation to practice, and I'm definitely relying on a tree to help me think through it. Good luck.